Hello everyone. So in the previous video we had talked about the theory and the practices of centrifugation. In this video we are going to talk about or solve a few problems about centrifugation biotechniques. So some of the general problems that are generally asked in exams about centrifugation is here. The first question is, what is the applied centrifugal field? We need to find the applied centrifugal field at a point equivalent to 5 centimeter. So r is 5 centimeter from the center of rotation and angular velocity is 3000 radian per second. So we need to find g. We know r is 5 centimeter and we know omega, angular velocity, is 3000 rad per second. So we all know this. We will use simple formula, G is equals to omega square R. So that would be very easy to know. G is equals to omega square R. So omega is 3000, so we will have 3000 square into R, which is 5, is equals to so 9 into 5, which is 45, into 10 to the power 3 into 6, which is 10 to the power 6, or we could write as 4.5 into 10 to the power 7. We could also write it as this. So this is G, or applied centrifugal field. So it was simple. Let's go to the next slide. So here we can see the answers. So we can see the answer here. Like I said, G is equals to omega square R. Omega is 3000 square into 5 centimeter R is equals to 4.5 into 10 to the power 7 centimeter per second square. So that's the applied centrifugal field, G. Let's go to the next question. So question 2. For pelleting the microsomal fraction from a liver homogenate, an ultracentrifuge is operated at the speed of 40,000 rpm. So we know rpm is 40,000. Calculate the angular velocity, that is omega. We need to calculate omega in radians per second. So this is the simple formula. Omega is equals to 2 pi rpm, revolution per minute, divided by 60. So this is a simple formula, of course. So what we would do, 2 into pi is 3.14, like here 3.14 into revolution per minute, that is rpm, is 40,000 given in the question. 40,000 rpm divide this whole thing by 60. It's a simple formula to remember. So divided by 60, and this is the answer. 4188.8 radian per second. So this is the angular velocity. So this is the question 3. In a particular experimental setup, mitochondria were isolated at 8000 rpm, that is rotation per minute. So we know the rpm. Calculate the centrifugal field at point 7 centimeter away from the axis of rotation. So we know the rpm is 8000, okay, and the r, that is radius, is 7 centimeter, right? This is 7 centimeter. We need to find the G. Calculate the centrifugal field. So we need to calculate G. So it's also an easy question. So for calculating G, first we need to calculate omega, right? We don't have omega either. So we know the formula of omega is equals to 2 pi rpm divided by 60. That is the formula of omega. So this will be equal to 2 into 3.14 into rpm is given 8000. So into 8000 divided by 60. So omega will be equals to, omega is equals to 837.33 radian per second, right? So this is omega. We calculated omega, right? Now from omega we need to calculate G. So G is equals to omega square R. So we will put the omega square here. 837.33 square into R is 7. So G will be equals to 4.91 into 10 to the power 6. this is the value of G. So it is easy to calculate. I'll show you clearly one more at the next slide. So yeah, so this is the answer. So we know the RPM is 8000, the R is 7 centimeter. We need to calculate G. So first we will need to calculate the angular velocity, which is omega equals to 2 pi into RPM divided by 60. So 2 into 3.14 into 8000, which is the RPM, divided by 60. Omega, we calculated the omega is here 837.33 radian per second. Now we need to calculate G in the first place. So here G is equals to omega square R. Omega is already calculated, 837.33 square into R is 7. So here it is calculated. So the centrifugal field at a distance of 7 centimeters from the axis of rotation of the sample is 4.91 in 10 to the power 6. So using these formulas, you can solve any kind of numericals about